All right, welcome back to Math That Matters. And if you recall, our main examples from our last class really revolved around the concept of interest. So we want to pick up right there, and we want to start actually with a pause, think question right out of the blocks. We're going to ask you to pause and think and answer the question, what is interest? Like in the context of financial math problems. How would you define interest? If you were going to explain it to, say, a first or second grader, what would you tell them that interest is? So think about that for a second. Okay, before we share with you our answer for what interest really is, we need to take a second and realize that interest really has two different connotations. One is when you talk about the amount of interest involved. I have a home loan right now, and I did a calculation this morning, and over 30 years, I'm going to pay about $100,000 of interest.
So you have to pay the bank back more money than they pay you.
Yeah, and the amount I'm paying them is $100,000, and that's considered interest. But there's a different way that interest is thought about. And that's when we talk about an interest rate, Pete, right?
Yeah.
What does that mean?
Yeah, so thus far in the inputs and outputs for the formulas that we've shown you, we have given you interest as a rate or as a decimal, a percentage that we turn into a decimal. And so what that really means is the amount of interest is based on the amount of debt or the amount of a purchase price or something like that. So what we really have been doing is just taking a part of what's there. You can even look at, say you buy a pair of shoes for $50, but they're on sale, 25% off, which means you don't pay all 100%. So you pay 75% of the $50, and then you just take 0.75 times 50. You've learned that in high school classes. And if you multiply a number by 100%, it stays the same. If you multiply a number by something a little bit bigger than 1, the answer is a little larger. And if you multiply a number by a number smaller than 1, like 0.75, that number gets reduced. So to take a percent of something, you just multiply.
Excellent. And you really need to have in your mind kind of separated, am I talking about an amount of interest, which we're going to use a capital I to represent that? Or am I talking about an interest rate? Because our problems will have both of them.
Yeah, they will.
They'll have an interest rate in them that helps us calculate an amount of interest. There's obviously a relation between the two, but we use the words interchangeably. When I say interest, I may be referring to a rate, or I may be referring to an amount of money.
So you're saying that I have to read the story and figure out if the story is talking about it like this, or if the story is talking about it like this.
Yeah, and one of the clues is if you see the percent sign, then you know it's over there, but you have to be clear.
Absolutely.
Now, regardless of whether we're talking about interest as an amount or interest as a rate, Pete and I want you to think about interest as a fee that's being charged for the privilege of borrowing money. You see, when we borrow anything, at least most things in this world, a house or a car, or even some chairs from the Take a Seat company, we have to pay a fee for using that. And interest is that fee that we pay when we're using someone else's money.
I like
Does that make sense?
That makes a lot of sense. If you're going to give me money now, I'm not going to just have to pay you back that money. I'm going to have to give you a fee for having that money because you don't have it and I have it.
That's right. So in this context, an interest fee is the exact same as a fee to rent a car or a house or a bike or even a pair of shoes if you can do that.
A fee to rent money.
Yeah, exactly. Okay, so we want to figure out how is it calculated. Well, there's a real simple formula. Let's look at it. Okay, the concept of calculating interest is really similar to the concept we used when we were calculating our expensive Christmas chairs. We found the total cost by taking the number of chairs times the rate times the time. Now, we made some mathematical mistakes regarding rate and time, but we've already talked about those. Over here in interest, it's the exact same thing. I've got 3 terms that make up an interest calculation. The first is the principal, which is really how much money. That's very comparable to how many chairs you were borrowing. The second is the interest rate that Pete explained what that means. And the third is the time, which is the length of the duration. Notice the similarities in the formula. So it's a really intuitive process.
So in the previous example from the other lecture, we were talking about some chairs and the cost of renting the chairs. And we figured out that when we took the, I think, 400 chairs times a rate of $49 per chair for every week, and we multiplied it by the time, which was 8 hours, we got $156,000 for renting just some chairs for 8 hours. That doesn't seem right, and I'm sure that our audience has figured that out. But you tell me where the mistake is, because it seems like 400 times 49 times 8 would get me the correct answer, but I know it can't be correct.
Well, it's the same mistake that we want to stress here, is that the major problem that we see in using this formula is that people make an error that their rate and their time don't agree mathematically. In mathematics, if you're going to multiply two variables together, the units have to agree. And saying per week times hours doesn't agree. So we have to turn those 8 hours into weeks somehow. Now, I had a student once say, that's easy, I'll just call it 8 weeks. Well, you can't do it that way. You have to think it's still 8 hours, but you have to describe 8 hours in terms of weeks, which is kind of tricky. It involves doing some division and converting units, and you can work on that later. But if you fix that, you'll get the right problem, which is about $1,000 to rent the chairs, which makes a lot more sense for the Christmas party lives on, after all.
For $1,000, that's a lot for chairs.
Be careful when you use this formula that your rate and your time agree. If your rate is per year, your time has to be in years. If your rate happens to be per month, which we'll see sometimes, then your time has to be in months. Let's jump into an example and see how it works. Okay, often it helps to start with a real simple example to show a concept. So we've got a simple one here. We're going to take $100 and place it in an account that earns 6% simple interest. That's the first time we've seen this term simple. It just describes a certain type of interest that is calculated using I equals PRT. And we're going to leave it there for 9 months. And the question is simply, what interest will be generated in this 9 months from this problem? Now, Pete, let me ask you first of all, is this an investment problem or a loan problem?
Well, the way that it's phrased, $100 placed into an account, the only reason you would put your money into an account, other than safety, is that it might generate some interest, that you would get some money back. So from your perspective, it's an investment. From the bank's perspective, they're kind of borrowing your money, so it makes sense that they would pay you back a rental fee.
That's right. So the bank could say that we are borrowing $100 from you and paying you 6% simple interest.
And they're happy to do it.
Yeah, and it's going to be the same amount of interest because what they pay is what we get. Okay, well, this is a really simple problem, and I think we can use our trusty formula, I equals PRT, okay? P stands for principal, which is how much money was involved. That's pretty simple. It's $100, all right? If I go too fast, Pete, slow me down. I'm kind of excited.
Just go.
Interest rate is 6%, so I'm just going to put a 6 in there, and it's a 9-month problem, so I'm just going to do the math here, and yeah, $5,400. So boom, that feels pretty good.
I would do that.
Let's go invest some money.
I would do that. That seems like a great deal. So $100 turns into $5,400 in 9 months.
And this illustrates a point called the gut check. Guys, you need to check your answers. And I don't mean check them mathematically. I mean check them with your gut and your head.
Yeah.
Does this make sense? Of course not, because everyone would be putting $100 in the bank everywhere. Yeah. This is absurd. Pete, what mistake did we make?
Well, I mean, they could pause the video and
good
figure
idea.
out what mistake was made.
Yeah.
So go ahead and do that if you want to. Maybe you've already seen it. However, I can see one for sure. And I already told them in this previous video. So you must not have been paying attention, Neal, but that 6% cannot be a 6.
Okay, that's right. Yeah, I got to fix that. 6%. You taught me how to do this. 0.06, 0.06.
And keep in mind, this is called an annual interest rate, which always is given in terms of per year.
It didn't say how often it was, does
so
it?
if it doesn't say per year, you have to assume that it's annual interest, which means a percent or a part per year.
Good, okay. Well, if I do that calculation, I'm just taking 100 away, so I got $54, Pete. How's the gut check feel on that one?
I mean, I did pretty good because I started with 100, I end up with 154. So I got more than 50% return in 9 months. That's a pretty good deal.
It feels a little high. Yeah, doesn't it feel a little high to you guys too? I think that's too much. You can't put $100 away and come back in less than a year and have $50.
Yeah, especially since it's 6% per year.
Yeah. So Pete, unpack what our mistake was, a second mistake.
Yeah, so if you were to write the units out on the 6% per year, and then you would write the units out on the 9, which would be months. That's the lack of agreement in the unit. So if this is going to be per year, then this has to be in years. We actually didn't even invest it for a year.
Well,
And
how do
so-
I say 9 months in terms of years?
It would be 9/12 of a year, wouldn't it?
Okay,
Right?
yeah, 3/4. I'm just going to put 9 months as 3/4 of a year.
I like that.
And now I have 3/4 of a year times 6% per year. And there's the agreement that we had to have in our units. And, well, it's not so exciting
Right.
mathematically anymore, but I did this, Pete, and I got $4.50. And I'm going to do something we want to encourage you to do. I'm going to box this answer, and I'm going to say, boom. We call that a boom box.
I like
All right? Yeah, boom box.
I grew up in the 80s. So
Yeah,
we had
did you
different
have a
kinda-
boom box? Yeah, so.
A ghetto
uh,
blaster, yeah.
When you get an answer in mathematics, don't do it with the wrong answers, but we want you to put a boom box around it, which means that's my final answer. And you can even say boom out loud.
I would write boom. I would write
yeah,
it.
Boom, yeah.
Because it seems like that just puts some authority.
Yeah, I had a guy in my physics class one year, and he said boom during every test on every problem. Yeah,
love it.
he missed almost every single problem. But during the test, it'd be like, boom,
Yeah,
bam,
yeah.
bam. And I was like, that was really cool. And then I graded his test, they were all wrong. But it was good. That's the idea, okay?
Yeah.
So that's the
At
right
least
answer.
you got one idea.
I gave him extra credit just for the booms.
I
Yeah.
would.
But this gut check works. If I put $100 in the bank for less than a year and I go back and they gave me $4.50, why'd they give me $4.50, Pete?
Because they were renting your money.
They were. They rented
Yeah,
my
and
money.
remember, 6% annual interest, it means 6 out of every $100. So if it would have been a whole year, this would have been a 6, right?
Right.
So we end up
Okay.
with $104.50 back in our pocket.
Okay, so we have our $4.50 of interest that we already calculated, but the real question that you want to know is when I go back in 9 months, how much money will be in the account? And Pete already mentioned this, but this is called the future value. If you remember our sweepstakes problem, this is the secret of solving that. What is the future value of those two options? It doesn't matter how much money they give you now. It matters how much there will be at the end of 30 years, right? So to find the future value, it's real simple. It's a simple formula. You take the principal that you started with, and you add in the interest. It's a very, very easy concept. And I want to use it, though, to illustrate something. If we unpack this formula, we find that there's another formula for interest that says interest is the future value minus the principal. And I know that's simple, but this can be a very helpful way to think about interest. That interest, the amount of interest, is equal to whatever you end with minus what you start with. Pete, silly example. If I were to loan you $10 and said, you got to pay me back $12 in a month, I would never do that to you, by the way, Pete.
No,
Right?
I mean, I would give you the $10.
No, I would, yeah. But how much interest did I charge you?
That'd be $2, right?
Did you use I equals PRT to solve that?
No, it was easier than that.
Yeah.
I figured out that you were just talking about interest being the rental fee on the money.
Excellent, yeah. So although interest is I equals PRT, and that's an important way to calculate how much interest given a problem. In fact, that's what we had to use to find this. The more important conceptual understanding of interest that we will come back to over and over the next several classes is that interest is the difference between what you start with and what you end with in a calculation.
Makes sense.
That's simple. All right, now we can take this mathematically and do some cool little things with it. Since I is PRT, we can sub that in, and now we do some fancy math that we're not going to spend too much time on.
Yeah, Neal's just showing off now.
You can pause the video and enjoy this, all right, show it to your parents. But we factor a P out, and we get a fun little formula. And what I want you to notice is it's our second simple interest formula. There's no I in this formula at all, is there, Pete?
It's kind of cool.
Yeah, it says that the future value is the principal that you start with times the parentheses 1 plus RT. And in fact, we could have found our answer of 104.50 if we just would have put 100 in here, 6% in here, and 9 months in there.
Ah.
Right?
So instead of doing 2 steps for a problem, we could embed it into 1 step.
Exactly.
Clever.
And I would argue that although interest is not in this calculation, it actually is implied, isn't it?
Absolutely.
Interest is the difference between those two guys, so you know what it is. So here's a second formula that's sometimes useful in solving problems. We're going to ask you to pause the video and to do a little exercise, a BLQ, and it's a real simple exercise. We want you to take the 4 variables that are listed in this formula, and we want you to write definitions for them. Okay, for our second and final example, We have a $2,700 principal. And notice I'm not saying if it's a loan or an investment because I don't care. And we have 9% interest. And Pete, there's a couple implications, aren't there?
Yeah, so it's simple interest. That's all we've talked about so far. And it's annual interest, which means it's yearly interest.
So if things aren't stated, that's what you
Yeah.
assume from
What's
now
in
on. It's
blue
simple.
will not be there most of the time.
Right.
But that's
And
what
it's
it
for
means.
18 months, which you know could be 1.5 years. I want you to tell us, what might this question be asking? This is like Jeopardy. What is the question?
What is it?
Find, what are they going to ask us for? I hope you came up with two possible things. Number one, they could ask us for how much interest there was, which you would calculate with I equals PRT. Number two, they could ask us what the future value was, which you could calculate one of two ways that we showed you in the last example. So go ahead and tackle that, and we'll see you next class.